Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 853 car fleet. There are n cars going to the same destination along a one-lane road. The destination is target miles away. You are given two integer array position and speed, both of length n, where position I is the position of the ith car and the speed I is the speed of ith car. In miles per hour, a car can never pass another car ahead of it, but it can catch up to it and drive bumper to bumper at the same speed. The faster car will slow down to match the slower car's speed. The distance between these two cars is ignored. They are assumed to have the same position. A car fleet is some non-empty set of cars driving at the same position and the same speed. Note that a single car is also a car fleet. If a car catches up to a car fleet right at the destination point, it will still be considered as one car fleet. So they will meet each other and form a car fleet. Return the number of car fleets that will arrive at the destination. So for this example 1, target equals 12. There is a list of positions corresponding speed. The car starting at position 10, traveling at speed 2, meet a car starting at position 8, and then traveling at position 4, and then form a fleet. This car starting at position 8 catch the car ahead of it at position 12, right at the target point. The car starting at position 0 does not catch up to any other car, so it is a fleet by itself. The car starting at 5, traveling at speed 1 and 3, becomes a fleet, meeting each other at 6. The fleet moves at speed 1 until it reaches the target. So basically, after two cars meet each other, they form the same fleet, and then they're traveling at the speed of the slower car. Note that no other cars meet these fleets before the destination, so the answer is 3. In example 2, there is only one car, so that's why it is only one fleet. In example 3, target is 100, and then the car starting at position 0, traveling at speed 4, and then car starting at position 2, traveling at speed 2, they become a fleet. They meet each other at position 4, and after that they travel at the speed of 2. Then this fleet actually meets the car starting at position 4 in position 6. The fleet then travels at speed 1 until it reaches the target, so the output is just 1. So how to solve that? I asked myself the question, how to form a fleet? What is the logic in determining whether or not two cars can form a fleet? So remember, the car that are, suppose we have two cars. Car A is closer to the target, and car B is further away from the target. Compared with car A, car B can catch up to car A and form a fleet. If the time takes B to reach the target is less than or equal to the time takes A to reach the target. So let's try to validate this idea using the example. So for example, in the example 1, for car starting at position 10, traveling at speed 2, the time takes this car to reach the target is the distance to the target, which is 2, divided by the speed 2, and then the time is 1. The second car, traveling at speed 8, traveling at speed 4, starting at position 8, traveling at speed 4, and then it takes it 1 unit of time to reach the target. So that's why these two cars meet each other. We can also validate the same idea for cars starting at position 5 and 3. So starting position is 5, traveling speed is 1. It takes 7 units of time to reach the target. And then car start at position 3, traveling at speed 3, takes 3 units of time to meet the target. So this car initially start behind car A because it start at position that's further away from the target. However, it's traveling at a faster speed, and then the time it takes it to reach the target is less than the time takes this car starting at position 5 to reach the target. So that's why these two cars can meet each other. There is a key point in this problem is that, okay, once one car catch up with the cars ahead of it, it will drive at the same speed. and then this speed is actually the speed of the slower car. Then let's code this question. So we keep track of the time, and then initialize this one to none. And then we also count the fleet. Initially, we initialize this one to 0. And then we are trying to sort the position and target and the speed. So what does this line mean? So for zip is a way to combine the two lists into a tuple, and then it's a very Pythonic way. It's actually very fast, so that's why we prefer zip. So basically, they convert these two lists into a list of tuples. So basically, a pair of position and speed, and then we sorted them. So based on position and then speed. After we sort them in the increasing order that comes with the default sorted function, we kind of reverse them so that the first elements in this sorted list will be the pair with the largest position, so which means the car closer to the target. And then we calculate the time to destination. That equals the target minus the position. So what is the distance to the destination? And then divided by the speed. And then we compare this t. So if this t is, let's say, not able to meet other cars and form a fleet. So in that case, if this t is greater than the previous time, so it means it cannot catch the car ahead of it. Or if this previous time, or which means, okay, it is the first car. In that case, we increase the count. So because this car cannot form a fleet with the cars ahead of it, so in that case, so we increase the number of fleets by 1. So right now, because this car cannot catch up with the previous car to form the same fleet. By previous car, I mean the cars ahead of it, or the cars that are closer to the destination compared with this car. So this car right now, it's a fleet of itself. This car may form a fleet with the cars behind it, but right now it is a fleet of its own. So that's why we increase the count by 1. And then after that, we know this, okay, now we have a new slower speed. We have new slower car, or it's longer for this car to reach the destination. So that's why we updated this previous time to this longer time. Why we are updating this previous time to this t? Because currently t is greater than this previous time, which means, okay, it takes the longer time for this car to reach the destination compared with the cars ahead of it. That's why this car is more likely to be caught up by the cars behind it compared to the other cars ahead of this car. Because the cars ahead of this car take shorter time to reach to the destination. That's why previous time is less than this t. Else, what if it can form a fleet? If it can form a fleet, then we know that we are not creating another fleet. So that's why the count remains the same. And then what if it be able to catch up with the car and meet and form a fleet? In that case, this fleet travels in the same speed as the slower car. Slower car means takes longer time to reach to the destination. That's why we are not updating the previous time, because else, in that case, the previous time is greater than or equal to t. So this is the takes longer to get to the destination. So in this case, this previous time still remains as the previous time. We do not need to update it because the fleet is traveling at the slower speed. So that's why there's nothing we need to do for else condition. We can just loop through all the cars and then we can just return the count. So my position from top from this sorted list is P and S. Okay, so I think I can change this way. If not previous time, or t greater than previous time. If you like my video, please don't forget to subscribe to my YouTube channel. Thank you.